Well, hello there boys and girls. Welcome to this flip clip on significant figures. Now you're clever clogs, so I'm assuming you know how to read scientific notation already. By the end of this, what I want everyone to be able to do is know the number of significant figures, recognize and count them, link that to communicating accuracy, and round off to the number of least significant figures. So significant figures in science give you an idea of the accuracy. And an example might be, if you just go out and you do a jog and you run 2 kilometers in about 15 minutes. But if you were racing at school over 100 meters, you would want to be, recording a lot more accurately. So with a few stopwatches on you, you might do 11.78 seconds. So just look at those two numbers. This one is like, 15 minutes, about that. Whereas when you run 100 meters in a race, you really want it to be very accurate. And the way that we've shown that is by giving more significant figures to this measurement here. So now for a science example. Year 7 will often get out a beaker when I ask them to measure 100 mils. So I'll write that there as 100. But Year 7 is stupid, we all know that. You should get out a measuring cylinder to measure 100 mils. And that gives you a much more accurate number. Let me explain why that accuracy comes from. This last number here has a little bit of error. This last number here has a little bit of error. So the 100 could be, as much as 101, it could be 100, or it could be 99. Down the bottom, this 100.0 could be 100.1, could be 100.0, or it could be 99.9. Look in the spread. At the very top, we have a difference of 3. At the bottom here, we have the difference of 0.3. So by adding the extra significant figure on this number here, it tells the reader that we are very confident about that number. It is much more accurate. So we've added another significant figure on. That's the big picture anyway. Shamelessly stolen from page 528. If you want any more information, that's a great page to read. What is a significant figure? We'll pause here and read through, but I'm just going to keep on talking. A significant figure is any number that is not 0 or any 0 that follows a not 0. Seems a silly thing to say, but a non-zero number might be just, 7. A 0 that follows a non-zero integer could be like 70. This number here, the 7, has 1 significant figure. This number here, the 70, has 2 significant figures. Now let's extend that to decimal places. So for instance, 11.25 meters, that's all non-zeros, so that's 4 significant figures. But if it's 10.21 seconds in the example, these ones here are non-zero, 1, 2, 3, and this one here is a 0, but it's to the right-hand side, so that actually counts as significant. So that is also 4 significant figures. This is a difference here. A 0 that comes before any integers, so on the left-hand side, is not significant. So, like your secret agent, your 007, why would you write these 2 zeros? It's dumb. It's just 7. So these 2 zeros are non-significant. So that's just 1 significant figure. The decimals is where it gets you, though. So that number there is 0.0004. That actually only has 1 significant figure, and it's the 4, because all of these zeros are to the left-hand side. They don't count. Think that's weird? Here's another way to explain it. This number here, I could just move that decimal point 1, 2, 3, 4, and that would give me a final answer of 4 times 10 to the minus 4. That does make it a little bit easier to see that it really is just that single number, and that's why it is 1 significant figure. Okay, let's recap. A significant figure is any non-zero and any 0 to the right-hand side of a number. Any 0 to the left-hand side of a number is not a significant figure. So now I'm just going to write down some numbers, and for each number I want you to count the number of significant figures. Then hit pause, because then I'm going to tell you the answers. Okay, there you go. Hit pause now, and I'm just going to go through after this and tell you the answers. Pause. Okay, we're back. Now here are the answers. This is just one significant figure. This is one, but that one's on the right-hand side, so the answer there is 2 significant figures. The 41, well, they're both non-zeros, so that's 2 significant figures. 41, and then there's a 0.2, so both of them, actually all 3 of them count, 3 significant figures. This one here has a 1. It's got some zeros, but they're on the left-hand side, so they don't count. So that's 1 significant figure there. 0.021, again, those 2 zeros are on the left-hand side, they don't count. That number has 2 significant figures. 4 times 10 to the 3, well, that's just 1, because that's the 4 there. So 1 significant figure. And this last number here, 4.0, zeros to the right-hand side, so that counts. That one's 2 significant figures. So what does this actually mean for us in chemistry? Well, if we're doing a calculation, our answer is limited by the least accurate number. And the least accurate number is the one with the least amount of significant figures. So over here, mass is 14.0, that's 3 significant figures, and the volume is 2.0. So that's your least accurate number. The question is calculate density. Density equals mass over volume. Mass here is 14.0 grams, and volume is 2.0 milliliters. You do your maths as normal. The answer is 7 grams per mil. But how many significant figures do you put in? And you do have to put them in because you have to tell the reader how accurate the number is. Well, you could put in 3 significant figures, but that would tell the reader it's very, very accurate, when in reality, this number over here was limited to 2. So you have to round off your answer to only 2 significant figures. Best practice would be to write that in brackets. And I know you guys already write, decimal places in maths. It's the same thing here, except we're writing it in significant figures. And that's enough for today. This is just to give you a quick taster so you don't freak out when we do this later on in class. And, the more accurate we get and the better reporting you have, the higher marks you'll be able to access for your lab report. You must be able to recognize and count the number of significant figures and then limit your answer, rounding your final answer to the number that has the least significant figures. Au revoir.